This approach is pretty good. I can't complain a lot when I see things like this.
And the concurrent hash map. That's great. That's smart.
My only complaint with the names you chose here would be that it doesn't tell you what's expected.
Hey, welcome to Dev Better. Today, we're going to talk about code that we are proud of, which is exciting times. We've done one episode about air quote bad code, and that was fun. And I got the same crew with me that I did with that particular episode. Jeremy Wood, Maharshi, why don't y'all go around the room? Let's start with Maharshi. Say hi.
Hey, my name is Maharshi Dubasi. I am a regular software engineer here at 7Factor, and I'm glad to be here.
Nice. And Jeremy.
I'm Jeremy Wood. I'm a staff engineer at 7Factor.
Awesome. This was so much fun when we kind of talked about bad code that we thought, hey, let's do this with things that we're proud of. So we actually all three have some examples. Yes, I have an example. You can make fun of me in the comments of code that we've written over the years that we thought was pretty good. And note that we're going to definitely probably rip it apart because as anyone has experienced, when you look through old code, you're like, wait a minute, what? I thought that. So we're just going to take a live code review. Let's start with Maharshi. You have a really cool Lambda and a test that we want to discuss. So why don't we just start with the test, or maybe you tell us what business problem it solves, and then we'll start with the test. You talk about what you liked about it.
Yeah, absolutely. So start with the business problem. So we here at 7Factor love to use Actionable Agile, which is a tracker of sorts for our stories, helps us keep in time, and also helps us estimate how long things will take. Well, there are some cases where our stories are not necessarily compatible with Actionable Agile. And so what this does is it makes them compatible. It rips all the necessary information and then just plugs it into Actionable Agile, and voila. So moving to the tests, what this test does is make sure that A, the information that we're ripping apart is consistent, and B, that whenever we're sending this information to Actionable Agile, it's organized properly, because Actionable Agile doesn't like it when things are out of order.
Right, for sure. It looks good. I think, so let's talk through, first off, what you're mocking. What are your thoughts? Why did you mock the things that you did? One of the primary challenges that I often see in writing tests is mocking too much or too little. Do you think you got it right on this one?
I think so, yeah. So usually whenever I'm mocking, I specifically mock, in this case, the end point, like the final point where it's sending information to something else, because that's not going to happen in a test. And so whenever you see me mocking the HTTP client, that is what that is. And then the other thing that I'm not necessarily mocking is I'm making a fake class. So for example, the environmental config, right? I'm just making a new environment config. Same thing with the Lambda and the service.
Right.
They're not mocks, but they are copies of the original class.
Right, for sure. And we tend to like to mock, or we tend to avoid mocking anything that isn't a system boundary here. Or things that there are certain things that you want to have control over when you're mocking. It really depends on the situation, but I do think you got this one right. I do like the way that you've set it up. With respect to, you have now control in the environment config, you have control in this in the Lambda itself to throw exceptions and test certain exceptional positions. That's to me one of the strengths of mocks and how you approach it. Do you think do you think that your first test here, get stories with valid request returns okay response? First off, I want to talk about this. I also name my test this way, but some people hate this. Why did you name your test like this? I think Jeremy hates it.
So I came from hating this type of stuff. And the reason is because I like my test names to be super short and succinct. But sometimes when you have, crazy amount of endpoints, it's hard to be succinct and also refer to the specific endpoint or the Lambda that you're talking about.
Yeah.
And so working with Diago and writing tests out for all that endpoints, right? All those endpoints helped me kind of fall in love with this because it specifies the endpoint, the information that's going in, and what it's returning. So it's pretty straightforward.
Jay Wood, did I put words in your mouth?
Maybe a little bit. I mean, I think this approach is pretty good. I can't complain a lot when I see things like this, the names like this for tests, because it is clear what's what the what methods under test, what the expectations are, what the setup kind of stuff is. I mean, the only way I see this done better maybe is when you use like a display name property where you can just provide a string that can use spaces and
Yeah.
commas and stuff like that.
Yeah, really, this is just about what I like to see is when you're running your tests in the console, you see like every single test with a check mark beside it, and you can kind of scan and quickly understand which tests are failing and which tests are succeeding. But I do agree with that, but also I don't know, there's the flip side of I'm in the IDE, I can also kind of run these tests one at a time. I don't know. I'm with you. It makes sense, but at the same time, I use the same testing methodology in some code that I'm going to show y'all, and I liked it because I was running them on the console and could kind of read everything that's going on as it goes. So, do you think that this test, Maharshi, is testing enough, or is it testing too much? Because one could argue that this function is too big. Your first test here, get stories with valid request. What are your thoughts on how big that is?
So it seems big, but really it's specifying, the exact things we're testing. This is a happy path test. So everything's going to function correctly, but we want to make sure that in the end, whenever, we're doing that return, we're making sure that the types are correct. The array is actually filled and that, we're asserting that the size is actually correct. So yeah, I feel like I'm testing the right things.
What do you think about that, Jay Wood?
I mean, there is a technique that is available, at least in Java. I would assume there's something similar in. Wait, is this Java? This is Java.
Yeah, this is Java.
Okay.
Yeah.
Well, there you go. So in Java, there's in JUnit you can do nested tests, and so I think, and so with the combination of nested tests and using those with before steps, so before each, you can do all of the setup in kind of one place, and then you have like a nested block with the setup that is shared, and then you can have shared setup that you can use between multiple tests, and then the test methods themselves end up just being like the assertion, and so you can make it shorter and more organized like that, but this is pretty standard, I think, otherwise.
I also think in this case, like there's only 2 tests in this, right? So one of the times when I start doing stuff like that is after I have written 1 or 2 tests that require similar to setups, where it makes sense now for me to refactor and say, this is a thing that people don't do that you should do. You should refactor your tests. People are afraid of that because they're afraid that if I refactor the test, I change sort of the specification or the definition of what the test is actually testing. Well, I mean, you shouldn't if you're just pulling things out and putting them, like you mentioned, into nested tests and things of that nature. So I think here, I would say that I would be okay with this until I saw a need for me to pull some of those things out. But I'm more of a just-in-time programmer, right? It's kind of just opinion. And if you like to set those things up early because you'll need them later, perfectly valid. If you're like me and lazy and you want to do it later because you're like, I don't need it right now, also valid, right? Yagni. But I agree. There's certainly ways to make this more concise, which is why I brought it up. But I'm okay with this. If you were to hand this to me, Maharshi, I would give you a pass on this first test for sure.
Thank you.
Nice. So your second test is even smaller, and it sort of tests a different condition. Talk us through what you're doing there.
Yeah. So the first one tested whether, everything is correct. The information that we're sending to this endpoint is correct. But the second test is covering what would happen if we sent a bad request. So something that had malformed body or something that had a malformed query string, for instance. And in this case, specifically, I think we're sending a, let's see, what is this? The input. Yeah, so all we're sending here is just an empty request. There's nothing actually within it. And so given that, and it's trying to, parse the information within this request, there's nothing to be parsed. So it'll send you back, hey, this is a bad request. So that's pretty much all this is doing.
Right. And you're mocking you're actuating some of the apparatus behind the scenes where you're mocking what this response should look like. I like doing this in controller tests. It's a thing that I used to do a lot where your controller, there's lots of different ways to approach this, but I'm talking MVC design, right? Which is, I don't know if that's a thing these days, but whenever you have, my definition of a controller is a piece of code that's taking some JSON object, transformed into an object that's in memory, and then doing something with it, right? Passing that downstream to business logic. There's a million ways to architect this, but let's assume that it's just a baseline controller. One of the things that people usually don't test is what happens, again, if you get a bad request. What happens if I'm sending something to the controller that is going to cause it to go sideways, and they just assume that, well, it doesn't matter, like Spring's going to handle that for me. I like to test these because you want to control those exceptional positions in your code. One, for security reasons. There's plenty of reasons why you want to avoid garbage coming out of your controller method. And two, it allows you to be tighter on the business logic. And also, you need to think about your clients. You always want to be communicating with those downstream single-page applications or whoever's calling you. You want to let them know why things went sideways. And this is something that this type of test is really good for indicating.
I think it's a good way to make sure you understand what your bad request or bad response looks like, so that you can control that on the client as well.
For sure. And that's a behavioral thing, right? Again, something folks don't typically think about. I think we're kind of spoiled in a world of like whatever these new frameworks, fancy new frameworks are. Get off my lawn, hashtag. So I also want to go back up. You throw an IO exception. I was actually looking back at your first test, get stories with valid request returns okay response. You're throwing an IO exception on the test. Why are you doing that?
So before, whenever we pass in let's say we pass in a bad request, right? It never reaches to that point where it'll pull everything apart and actually parse it. It'll only ever get to that point if it's a valid request. So in that valid request, let's say that for some reason your JSON's malformed, right? Then it'll throw an IO exception. So
what you're telling me is Java is being annoying here.
Yes. Yes.
More flame wars in the comments.
Java is annoying.
I hate, this is one thing I hate about Java. Again, more flame wars in the comments. I really don't like method signature exceptions. It drives me insane from a maintainability perspective. But yeah.
And what's funny about this? Oh, sorry, I didn't.
No, go ahead. You're fine.
So what's funny about this is that it never actually throws the IO exception. I catch the exception and then I return, hey, such and such is malformed.
Right.
Bad request.
Yeah.
So yeah. And I have more tests on this. I just only posted two as an example.
Nice.
But yeah.
All right. So next, Jeremy is going to talk to us about some of his Minecraftery, which is kind of awesome and exciting. You wrote this. Tell us, what does this thing do? And we'll put a link in the description, obviously, to the repo. What does this thing do?
Yeah, this is a plugin for a Minecraft server that allows you to create like physical locks and keys. So you can lock a chest, and the player has to have a very particular item to go and unlock the chest.
Okay.
It's useful for servers where you want to provide kind of minimal protection for people's stuff, but like in a neat way that doesn't require typing in commands.
Cool. So awesome. So we're looking at lock registry. It's written in Java. So tell us a little bit about what this is supposed to do and why you think it's interesting. This is a pretty cool class.
Yeah, so the lock registry is just where all of the lock data is stored. So, we need to store the locations of the blocks that are locked, for instance, the chests or doors. I believe it works on doors and maybe even levers. And so we store all of that location data in a YAML file, most likely. It's been a while since I've touched this, so yeah. It's either it's a .dat file, sure, whatever that is. Yeah, it's like I said, it's been a while. But we just when this gets created in the plugin main class, it just loads up the data file and then does it off the main thread so that you can load data. I mean, these files are small, so maybe that doesn't matter. But hey, why not use it if you got it?
Yeah, for sure.
And so in the load locks, you can see we're using a feature here to submit the load request for the file. This method's maybe, the thing happening there probably could have been its own private method. And Yeah,
I
mean,
the two things that jump out me on load locks is, like you said, the try catch. Maybe that could have been its own sort of function, because on the lower hand side you have the try. You try to load the blocks. You do the lock loader.get, then you clean them up, and then you toss a log thing out there. But other than that, I mean, this is a pretty small function, right? It makes sense. The thing I like the most about this is that all of the function names are very clear and easy to understand. I mean, again, you're not really solving rocket science here. You're just basically building a stateful, kind of like a singleton style approach here. You have a stateful class that loads things not stateful in that we're storing a bunch of state in the class. I'm sorry, let me rephrase that. But it's stateful in the sense that it's very easy to actuate the apparatus. Oh, you do have a concurrent hash map. Never mind, it is stateful. So you're kind of loading, you're loading what you need, and then you're keeping it around in memory, and you have some very clean and clear call outs on what these methods are supposed to do and how they're supposed to interact, and the concurrent hash map. That's great. That's smart. That way you don't need synchronization across 15 different methods. So that's a smart call.
Yep. And so it does the load lock, loads from the file, and then at the end it actually calls this cleanup locks, which goes through and looks at the world, the Minecraft world, and makes sure that the locks in the world still match up with items that would make sense for the locks.
Very easy to read.
Then it removes that from the data.
Yeah, for sure. Very clean and clear, easy to read. Again, this kind of feels like a framework class that I would use, where the interaction is designed such that you kind of know what's going on. And I also like that you hide the concurrency, so I don't need to know about it, going back to not having synchronized on all the blocks. Anytime I'm using a class that has synchronized methods, I get freaked out because I'm like, I don't know if it's going to work or not. Or I don't know if I'm going to F it up and it's going to explode. And this is a great pattern that I love to see people do, where you hide concurrency where it's unnecessary for you to know about it. In some cases, that's not the case, but in this particular implementation, I think it's very cleanly hidden, so I don't worry about it.
Yeah, that is kind of one of the goals I had here, was all of the methods in here are kind of an abstraction over top of this concurrent hash map, so that the users of this don't know about the map. They don't care about the data structure. It's more about just like, what do we need to do with the locks in the lock data?
Right.
We can remove locks, and like you said, we don't have to care about the concurrency, because all of these methods are probably called from something off the main thread in the game, people interacting with the world. And so that concurrency stuff, since we can't mix that with the main game thread, we just don't want to have that interfere with anything. And this is an easy way to do it.
Yeah. I like setup connected chest. That's line 157. That's a really tiny private function that has a very clean job that it's trying to solve for. Overall, if you handed this to me, I would still, I think I have a little bit of trouble reading everything, just because there's a lot of stuff here. But the difficult thing is, when do we decide when to cut off, the job of a class? You know what I mean? Like, you could get super OCD about this and bust it into 15 different tinier classes and all this and that. But I feel like I like to right size things. I'm not an advocate of going super hard into that direction. If it makes sense and it has a clean job and it does the job well, I don't think you need to break it into smaller components. So I think this is actually a good example of kind of right sizing what you're trying to do from a data structure perspective. So what about tests? Did you, I'm not seeing any tests in your...
There's testing in Minecraft stuff is very difficult.
I would imagine so.
You end up having to mock pretty much the entire server, which is just not feasible in most cases. There's actually a newer thing that exists now, though, called Mock Bucket, which is a library made by third parties that attempts to do just that. They try to mock pretty much all of the classes on the server, so that you could write tests against it. I don't think that was around when I made this, so it's just you write the code, deploy it to your server, make sure it works.
Yeah, no,
old school.
That's a lot of game programming, man. I think game programming is a totally different world than what we do every day, which is why it's kind of fascinating and fun to live in. But yeah, that's it. It is what it is. Maharshi, what strikes you as about this you think is interesting?
So yeah, like you said, hiding concurrency. I mean, the very first thing that I noticed was how load blocks was using a future map. And then the rest of my time, I was like, okay, where's the concurrency part of it? Outside of that, there should be other things here. Right. So that was pretty cool. And the other thing, as you brought up, would be
Mm.
tests. Theoretically, if you could, mock all the server, um, I think this would actually be a pretty straightforward class to test. You know what to write for, you know what's going into it, and you know what's coming out of it. So
Yeah,
yeah.
the only thing I see in here, unless data source is a part of bucket, like I see that you have a map of, well, no, you own that. So what in here? Bucket
Mhm.
task? Is that the only thing that's Minecraft based?
The block class and the
Ah,
player class.
yeah. Okay, I see it. Pure
So when we create
material.
locks, we need to know who the owner is, and
Yeah.
that would be the player. I mean, I'm probably only getting the name or something, or
Mm-hmm.
well, it's actually I think they use UUID now. But
Yeah. There's I see seven imports from bucket, so that would certainly be irritating to try and
yeah,
if you wanted to mock that full stack. I mean, honestly, the way I approach it, I try not to mock things if I don't need to. If I can create a new
mhm.
player class, these simple data classes, you just make them, right? You don't worry about trying to set them up and tear them down. But I think this is one of those cases where it's a data structure, so it kind of makes sense to try and mock everything and build sort of this insulated box that you test everything in. But I almost wonder, Jeremy, if you could have built a different class that was more generic and testable, and then
Mm,
instantiate that class
Mm.
as either composition or through some form of subclassing, which I generally dislike, so that you could test all of the sort of cool abstractions you have in here, and then in turn, have it sort of sit away from the Minecraft stuff.
yeah, I have done that before, and it's a lot of work.
It is.
It's a lot of work. I mean, honestly, a lot of the stuff I made for Minecraft, it was like I'm trying to build a lot of stuff for my server that I
Yep.
was running at the time, and I just
Mhm.
wanted these functionality to work. I didn't have
Mhm.
anybody helping me, so
Yeah.
it's like my people need ways to protect their items, and this is it's like
Yep.
I made it as good as reasonable as far as readable code. Um, the testing part, yeah, I mean, I could have done all that. What you're saying with like abstracting out the Minecraft parts of this, I have done that before. I tried to rewrite a big plugin in that style,
Mhm.
primarily so I could actually interface with more than just Bucket, which is only one of the possible server APIs. And man, it was a monumental task that I ended up giving up on.
It's tough, yeah. And I also want to say
Mhm.
that to most people if you're watching this in the real world, you want to follow the best practices that you can, but specifically I think game dev is a great example where you're not always given the scaffolding to test things. And how you test, like sometimes it's a manual test. You new it up on your server, you make sure it works, you fiddle around with it, maybe you try and break it a little bit. And then you just move on and try and figure out the next thing. But I would certainly think that there are some advanced testing techniques you could use here. But yeah, if you got to get it done, you got to get it done. Just make sure you come
I
back.
Yeah, I have heard of people actually testing with a live server. So
Mhm.
they plug in through like with debug mode,
Yeah.
and but if you break for too long, then it crashes the server. So
Well, that's
that's
a
always fun.
Minecraft problem. Come on, guys, fix your servers, right? All right, so the final one is my code. Feel free to make fun of me. I wrote this 7 years ago. There is an open source library that I wrote called Aptum Inc. Toolkit, and it's on my GitHub, github.com/jdove. And it has 199 stars and like 46 forks. So I'm guessing people are using it, which is kind of fun. The problem I was trying to solve, so this was back during my master's research, wrote a paper about using fuzzy logic to create inputs into unit tests, and then to randomly generate using this library called Randup the inputs for specific unit tests. But we also wanted to look at the DLL that's under test. This is written in .NET. Look at the DLL that's under test and inject into every single method our own bytecode that dumped the memory of a particular object on every run of a unit test. Okay. And so picture this. We run this set of unit tests. We dump the object state in this giant XML file that I invented, and then we get another version of your code with different tests, and we run the same exact fuzzed statistical kind of anomaly, shooting things into the method, and then we dump that and we diff the two objects. And when we diff those two giant XML objects, we figure out using some fun math that's in the paper whether or not there's a statistical probability that you have a bug. Again, I won't get into that. It's very super crazy and really deep. But this code that I wrote was to solve a specific problem of those DLLs, right? I need to be able to find a DLL and load it into memory and do some code instrumentation on it, and then find another DLL, load that into memory, and then run some additional code instrumentation on it. It's a very complicated business domain, right? And there was nothing in Microsoft at the time that solved this problem. If you try and work with assemblies in Microsoft, you literally, your head will explode. There's so many random little edge cases that they put in place that you have to understand to properly work with domains, what they call domains, that I'm like, you know what? I'm going to build a library for this. And so the file that we're looking at is app-domain-context.cs. That is kind of the entry point to everything that you're doing in this library. It's kind of the centerpiece of it's the thing that you new up. And there are a couple of static methods. I was a fan back then of static methods for creates, using sort of a factory-esque kind of pattern. So your constructor, I believe, is going to be sealed. Yes, it is. The constructor is sealed and quite complicated. But what I wanted is for you to call app-domain-context.create and to pass it the information that you care about. I used composition a lot. So the second create method, which is on line 32, takes in an app domain setup, which gives you all of the information that you need to configure this particular thing. And the thing I'm most proud about this is I took a very complicated domain and I tried to transpose it into some simple methods, just some simple ideas that you use to interact with. And you can even call functions in a domain. After you've loaded an app domain, you can call specific functions inside that domain that is insulated in memory from the rest of the execution of your existing code. So it was kind of a cool, fun little science experiment. It took me like 4 months to write this thing because it was super complicated. And I tested the hell out of it as well. I would argue my tests are pretty terrible. But at least I think it's like 80-something% coverage, and I was super proud of my commenting skills, which you can probably clearly see in this code. But what about this strikes y'all? Again, feel free to rip it to shreds, right? You're not going to insult the boss.
So for me to start, the first thing is, as you mentioned, comments. Just for the two constructors that you have, or three constructors rather. Like the first one says creates a new instance of the app domain context class. And then the second one also says creates a new instance of the app domain context class. So yeah, and then it's very clear that it takes in a setup info, and yet, line 27, the setup info.
Yeah, again,
so
comments, this is a great example of why comments are bad.
I mean, this is a pattern though. This is especially for documentation comments.
Yeah.
And I mean, like, there, especially, I mean, I know this in Java with JavaDoc, there's like tools that'll even tell you that like, oh, you're missing comments on this public method.
Yep.
Which, I mean, if you're building a library like set of code that's intended to be used as a library, then people expect there to be these comments, I guess. So, I mean, could it be written better? Maybe, but I don't hate this being here. It's just kind of bog standard, perhaps.
I think that's probably what I was doing. Is my thought process was, hey, this might be a library people care about one day. And this was back in the day of JavaDoc, right? If you remember JavaDoc days, where you would write all your JavaDoc comments and then you would generate a website that you would then go to kind of peruse and understand. And the JavaDocs are really good. If you go read Oracle or whatever it is now, the original JavaDocs, super good about explaining how and why you should do things, and all that's in code, right? That was my thought process, but I being older and wiser, I know that some of those comments are a complete waste of time. All right, so now let's pivot to, let's go look at the app domain context unit test for a quick moment, because Maharshi, you made a point on the previous one that tests are a great way to see what's going on. So let's kind of bounce in there real quick, and you're probably going to be appalled at the number of static read-only strings I have in there. But this was a pattern I think I've used a lot, and I don't know if I like it or not right now. I'm still sort of deciding, but instead of writing those strings in like the test themselves, I put them as a private static, asset on the test class itself. But there's a lot of complex, like this particular test is very complicated, but notice that I use the same naming patterns, right, that y'all used. Create no args valid context on line 34. These are just constructors, right? Line 46, create null app domain setup info, assert that we're throwing an exception. So I was making sure that if I give it a null, I get an argument null exception, which, one would argue maybe that's too granular of a test, but I was very much into ensuring that all paths were covered when I was writing the test for this thing.
I think my only complaint with the names you chose here would be that it doesn't tell you what's expected.
It doesn't. That's right.
It tells you like what the given conditions are, but not what we're expecting out of this. So it does require reading the test to figure out what's actually expected.
Right. And even on like the line 55, the first test, I have a lot of asserts in here. This also violates a pattern that you see in a lot of testing. Where, you have too many asserts. But I go back and forth on that, honestly, because I think there are times where, the old school rule of one assert per test just does not feel realistic. I don't know that I'm on board with that idea, but
that's a garbage rule.
Yeah, for this one, I think
it's more about asserting one thing,
one idea,
in that one idea, which may require multiple actual assertions.
Right.
So as long as you're not trying to say like, oh, okay, the thing is good, the app domain context is good, and it's the thing it produces like can create all these classes or something like that.
Right.
It's not doing that, and that's when I would say it's asserting too much.
Right. I think the bread and butter is line 153, 165, and 178. That's when we're actually testing to make sure that it loads, that the app domain context loads the appropriate app domain in memory. And those are very clean and straightforward tests. Like when you read that, you're like, okay, let's take again one line 53, dispose load assemblies properly. Assert throws an object dispose exception if I do the following thing. So that basically states that if the target is disposed, it needs to throw this exception, and it's a very simple setup. So you can read that and kind of know what's going on in a straightforward way.
So is this is saying like if it's disposed already, then trying to dispose it again is not going to work.
Right, and the reason, there's a business reason behind that, which I probably could have done a better job describing, like why are you testing dispose? Whenever you dispose an app domain context, all of the associated DLLs and app domains that you've loaded in also need to be disposed. And it can be very tricky if you're in a weird state or your DLL is loaded in a weird state, then it can put you in a position to where there's a bug there. So the reason I wrote that test, I don't remember all the details, but I believe the reason I wrote that test is to cover that edge case.
Oh, you're trying to get the assemblies and it's already disposed. There we go.
Right.
Okay. Well, you can see it's not entirely clear.
Nope.
Just without, maybe one more underscore and the, what's expected here.
For sure. And remember, this is grad school code, so.
Sure. Hey, it's not bad. I mean, it's a lot of tests. Like you said, you were trying to cover all these conditions. I think that's great. Did you do it TDD or was it after?
No, I didn't know what TDD was back then. And that's why you'll probably see that a lot of these tests are written in a very piecemeal manner, right? Back in school, we were taught one test per function, that whole stuff. And I didn't know what test-driven development was. I didn't even know what feature, like building, I didn't know that tests were designed to look at how a feature interacts. So I really took like a one-to-one relationship. So you can almost see every method and maybe 2 or 3 edge cases for a particular method on the branch, based on the branch coverage, will have that number of tests to make sure that all those those branches are covered. So unfortunately, I did not use TDD for this, but this was sort of the renaissance for me. This is when I started thinking about tests, right? And that's why it's over-engineered. Like there are too many tests and they're named weird and they're all complicated. Is because this was that period in my career where I just started being like a journeyman level programmer. And I'm like, wait a minute, I need to write tests to make sure my stuff works. And I saw the value of having regression on that. And plus, I had designed this to be something that people used, right, as an open source project. So I wanted to make sure that there was some level of quality in what I was producing. All right, cool. I'll stop torturing you with my terrible open source code. But I'm proud of it. Again, it was a cool problem. It was a cool problem space. There were decent tests there. But obviously, there is no such thing as good code, right? We say that with tongue in cheek. But this was great. I hope you all enjoyed this episode. If you do, like, comment, subscribe, and keep doing this kind of stuff. As a matter of fact, we have a really cool series planned out where we're going to be taking the Clean Code handbook, or the Clean Coder, rather, the big, not the Clean Coder, the Clean Code, the big one. And we're going to go through each chapter, and we're actually going to look at code and talk about how it aligns to the items in that chapter. And it's going to be the same crew, Maharshi and Jay Wood. Appreciate y'all. Thanks to everybody for watching, and we'll see you next time.